you can look up here. I'll always announce it too. We have a 1.1, 1.2 quiz, Zach, everyone else, next Wednesday. Okay, a week from today on 1.1 and 1.2. So we started 1.1 on Monday, Media Center yesterday. Today we're finishing 1.1. Tomorrow we start 1.2. Friday, I'll tell you what happens Friday. And then Monday we'll finish 1.2. I made up a quiz review worksheet for you on Tuesday, so you guys will know exactly what's on this quiz. I'm really trying to baby you in the beginning. But in class on Wednesday, we're going to have our second quiz. Guys. Then also, I haven't written it here. I apologize. I keep saying I'm going to do it, and then I'm so busy. But next Tuesday will be our first homework check. I will please, Austin, please don't. Okay. Where was I? See? Thank you. Homework check on Tuesday. The way I do homework checks is I'll do the lesson, whatever I need to do, and when I say, okay, it's time to work on homework or whatever it is, that day happens to be a quiz review, I will tell you what I'm checking. I'll say I'm checking A2 and A3 or whatever it may be. I don't check every homework assignment, okay? So my old students, you already know how I do it. It's the same way I did it in Algebra 2. And so that is why when I give you a homework assignment, I always write what the assignment number is at the top. Because the way, like in other math classes, it's like page 57, 1 through 10 or whatever. We don't have a book. These don't have numbers. So I label everything with A1, A2, A3. So when we get to the homework, I will remind you to be labeling your homework with the A whatever, because it's just easier to help you find them when I check. So I'll explain homework check much better next week. I don't want to waste too much time on it. But homework check on Tuesday. Wednesday is our second quiz. And I still am working on, I do have it figured out, but it's not, let me finish all the makeups for the factoring quiz. Then I'll tell you what I'm going to do for anybody that wants to retake it to forgive that other grade. Maybe you didn't do well and you know you could do better and you want to do it better. I will tell you how that will work in the next week, okay? But I just have to get through all the makeups first. I still have a few more left. Okay, so what we're doing, the beginning of this course, a lot of the 1.1 to 1.4 or 1.5 is a lot of teacher talk, okay? There's a lot that I'm explaining because I'm not just teaching a concept. I'm saying this is how you have to write it, and there's a rule about this and all that. Once we get going in the year, you'll just know a lot of these things. I don't have to say it all the time, and we'll get through my section of the class a lot faster to get to your part where you can work on the homework more in class, okay? That is always my goal, is to give you as much time as possible to work on your homework because I want you to get it done in class. That is my goal, okay? I want you to get it done in class while you have friends to talk to and get help from, while you have me, I have the key posted up here for you nice and easy. What you don't finish is homework. But that's one of the reasons I run this like a very tight ship. We have the assigned seats, I have a way of work, a way of doing things that makes the class run smoothly to optimize time on homework. It's really all for you, okay? I like teaching. I like being up here, but I want to give you guys time to practice in class. Okay, so here's what I'm talking about. Right off the bat, finishing up with change in tandem, our 1.1 section, we're going to talk about concavity, namely concave up, concave down. And you might remember from other classes, but if not, concave up is like a U. It's opening up. And concave down looks like a frown. Okay? And what we are going to learn and what we are going to memorize is that the rate of change is increasing on concave up and the rate of change is decreasing on concave down. Now let me explain what that means. We've already used these words, so just to confuse life a little bit, we used the words increasing and decreasing on Monday, if you remember, where we talked about a graph going up, graph going down, increasing, decreasing. Really simple concept, and we talked about intervals. And we'll review that today, what we learned on Monday. Everything we did on Monday is part of this lesson as well. Now we're talking about how the rate of change is increasing. Not the function is increasing. The rate of change is increasing or decreasing. Rate of change is simply slope, by the way. Rate of change is your slope. Also, we use the letter m. Remember slope intercept form, y equals mx plus b. we still use the word slope, we still use the word m. Now, at this level of math, we're introducing rate of change, okay? Rate of change, like I said, is slope, but we usually use that term, rate of change, on a curve. Here's what I mean. Back in like all your algebra classes, you would have a line, right, on the coordinate plane somewhere, okay? There's your x-axis, your y-axis. And if I asked you to find the slope between 2 points, whether you remember it or not, there's a formula for it. You could find the slope between 2 points by going up and to the right or whatever. That has a slope of 1. There's a slope of 1 here. If I go between these 2 points, it's also going to simplify down to 1. On a line, the slope is always constant. No matter what 2 points you pick, your rate of change, your slope, your m, is going to be the same, no matter what 2 points you pick. That is not true when we find the slope on a curve. That's what calculus is. It's all about curves and working with them. And so the very basic part of it, and we don't go deep into it, but what we need to know is that between any 2 points on a curve, so if I found the slope between these 2 points, which we'll do tomorrow, really simple, it's going to be different than the slope between these 2 points. And that's going to be different than the slope between these two. So when we talk about concave up and concave down, we're talking about the slope getting bigger or smaller. And I have a great visual for you. Don't write this down, you can just look. Now here's a great trick for you. I forgot to mention it. How do you memorize this? Because you have to memorize it, okay? Concave down starts with a D, and so does decreasing. So down, decreasing, up is the other one. So it's either increasing or decreasing. It's either up or down. If you pair these two together, you know the other one. That's never going to change, okay? So look at my concave down picture here. This is a great visual of, like between these 2 points, just trust me, the slope is 2. Between these 2 points, it's 1.5. See how it's changing? It's not constant. Like a line, the slopes would be the same. And they're going down. They're decreasing. 2, 1.5, 1.5. Up here, this is like a horizontal line. The slope between these 2 points is straight across. That's a slope of 0. Then see how we're tilting down? These are negative slopes. Bottom line is, from reading a graph left to right, the slopes are decreasing, getting smaller, okay? Concave up, reading our graph always left to right, think about a number line. We're further away from 0, getting closer and closer to 0. Again, it's that horizontal line, and then they're growing, okay? So in a concave up, the slopes are increasing. Concave down, decreasing. Concave up, increasing. Really, really important concept, okay? And we'll be diving into it more in the next few lessons, all right? So here's a picture of I just talked about it. Just one more thing to write here. Rate of change, because it's long, sometimes you'll just see ROC, rock. That's rate of change. Or we'll also see AROC, average rate of change. So all of these mean slope or the letter M. They all mean the same thing, okay? So let's look at a graph and pull some information off of it, okay? So the graph of g of x is shown above. Use the graph of g to find intervals where g has the following behaviors. So some of this is Monday's stuff and some of it's new, today's stuff. But what part of the graph is intervals? Remember we talked about, I screamed at you, not really. But what are intervals? What did I tell you to remember for intervals? What part of the graph? X-axis. Remember, when I'm asking for intervals, it's saying what part of the x-axis, what chunk of it, does this behavior happen, okay? Intervals is always x. Now there was some confusion because it was like pointing down, but it was also pointing to the right. I'll cover it here again. Okay, so back to Monday's concept. This is g of x, okay? Where is g increasing or decreasing? Not where is this rate of change or slope increasing or decreasing. Where is the graph? So this is that simple, basic going up or going down, okay? Well, increasing, okay, so I couldn't hear you, Zach. I'll come back to you. Let me say one other thing. On this graph, they gave us a bunch of ordered pairs. Okay, notice they didn't just label the x-axis, they gave us the ordered pairs. So where are we increasing? So if I just trace this, I'm decreasing, I'm increasing, I'm decreasing, I'm increasing, right? Just where am I going up or where am I going down? So increasing, what's my first section of increasing? Did you say it, Zach? Okay, let's work left to right. So I'm going down, and then when I get to -3, I start increasing. So remember, we use parentheses or brackets here. It doesn't matter. I go from -3. When do I stop going up? When I get to what number? 2. Again, brackets are fine too. All right, and then I go down. I'm decreasing, and then when I get to 4, right? When I get to 4, I start increasing again. And where am I going as I go up? I'm also going to the right forever. Okay. Where is G decreasing? So same idea, right? I'm decreasing all the way in this section right here. Now this section is going up, but it's also going to the left. Remember, intervals only have to do with what's happening left to right, x-axis. So the mistake we always see here, so easy to do, so be careful, is to, instead of putting negative infinity here, you put positive. Because our eyes see an arrow going up. That's what our brain really thinks, up. Oh, up is positive infinity. But that's what the y's are doing. The y values are getting bigger. What are the x values doing? As it goes up, they're going this way to the left, which is negative infinity. That's confusing, so start getting used to it now. Where does it stop decreasing? When it gets to -3. Do we have another part that's decreasing? Yep, right here, Zach, I think this is what you were talking about, from 2 to 4. Okay, I know exactly what you're saying. Thank you. He's confusing increasing and decreasing with positive and negative. Remember, positive is above, negative is below. Increasing and decreasing is, am I going up the hill or down the hill? Okay? All right, now, here's where we're going to talk about concavity. Concavity is going to be confusing in the beginning, okay? It's normal. It is normal. Because when you just glance at this graph, without me tracing it, I think you guys would agree with me that there's 2 sections that are concave up, roughly, right? Here we're going up, right? We're going down somewhere in here. We're going up here. You guys see it? We're concave up, we're concave down, we're concave up. So we have 2 sections where G is concave up. Naming them, again, we use the x-axis, okay, because we're doing intervals. And we haven't talked about what the rule is for naming concavity. Remember, increasing and decreasing, the graph increasing or decreasing, or positive and negative, we learned on Monday, brackets or parentheses, it doesn't matter. With concavity, okay, whether we're talking about where a graph is up or down, the rule is parentheses. You have to use parentheses. So maybe you guys have figured out at this moment why I like to use parentheses for increasing, decreasing, positive, and negative. When it doesn't matter, because concavity is also has to be parentheses. So I just use parentheses on all of these things, okay? When we get to the homework key, Jean Adams, the she I keep referring to when I talk about the notes in the homework, she is the lady that created all of this stuff. She creates all the keys. So when I upload a key, it's usually in her handwriting, and I'll say, ooh, I don't like how she did that. That's who I'm talking about, okay, by the way. So I'm like just talking about this random person. She, in the homework today, in the key, she put brackets around this stuff. I was going to change them all, and I was like, no, I want them to be comfortable seeing parentheses or brackets, because it doesn't matter on certain things, okay? And I don't take off either way. Concavity, if you use brackets, it's wrong, okay? It's a rule to use parentheses. Okay, so concave up, starting all the way to the left, that's going to be negative infinity again, right? This is all up. So that's negative infinity to the left. Where does that change? That's what's confusing. Where we change, it's not 2. And that's what I even said 2 first period, and I was like, no, I messed up. Okay, it's easy to think that from here to here is up, but actually, isn't this right here? If I can kind of separate it out. That's really concave down right there. It actually changes from concave up to concave down right here. That's confusing. It happens at this point, which is negative 0.5 is the x. So here to here is concave up. Then from here to here somewhere, we'll talk about that, is concave down. Where do we go concave up again? Where does it start? Where does it change from concave down to concave up? At what x value? Can you see it? 3. That is going to take some getting used to. Look at it closely. So we are concave down all of here. But if you look, this starts curving up again. Right there at 3 is where we start curving up. So it starts again at 3, and then it goes up and to the right forever. Okay? If you're confused by that, it's going to take some time. Okay? That place where we change from up to down is in the middle of increasing or decreasing, right? That whole thing is decreasing, but the concavity changes in the middle. That place where concavity changes, we will be learning about in lesson 1.4, is called an inflection point or point of inflection. And that's where concavity changes from down to up or up to down. That's what's tricky, okay? We're going to practice some more. Stay with me. Now, let's find where the graph is increasing and concave up. Two things. Well, we just found where we're concave up, so we can kind of, quote unquote, cheat. Go into these two sections and also just grab the piece of the x-axis, the interval, where we're also increasing, which means going up. So, back to negative infinity to 0.5. Where in there am I also increasing? From what to what? Yes, that's right. So this is decreasing, then we hit this point and we start increasing. So all of this is concave up. Where are we increasing? From negative 3 to negative 0.5. Okay, we have another chunk that is concave up. Again, from 3 to infinity. Where are we also increasing or going up? Where in there are we also increasing on the graph? That would be from 4 to infinity. Okay. Now let's switch to concave down. There's only one section. Yay, this is shorter. Concave down. So we're concave up. We switch right here, and we become concave down until here. So from negative 0.5 to what? Where do we switch? 3. It is 3. Let me outline it. Right there, we're concave down. Because if you trace it with your pencil, when I get here, I start curving up again. Okay, so this is where it changes from concave down to concave up. Where in that section are we also decreasing? 2 to 3. Just that little piece of the x-axis. This is stuff that you're going to see for the whole year with different types of graphs and things like that, so that's why I'm really trying to make sure you understand it. There's really not a lot in this class where you can say, I don't get that. I'll just not do good on that section. Because a lot of things come back, okay? And you're about to see that already on day 2 of learning the new material, how something comes up again. All right, let's go to the next page. I want to talk about, this is really an Algebra 1, Algebra 2 concept. Really nothing new here. I'm basically reviewing. But intercepts. What are intercepts? X-intercepts and Y-intercepts. We've already talked about them a little bit. But remember, intercepts are where the graph touches an axis, plural for axis. So x-intercepts are where the graph hits the x-axis. Y-intercepts are where graphs hit the y-axis, okay? And what I want you guys to notice is right here it says, when you're an x-intercept, y equals 0. That's what this notation means. Y equals 0. Why did they put an f of x there? Because we're being fancy. That's all. Don't overthink it. Y equals 0. And we already know that. When I name the x-intercepts on this graph, if I list them as ordered pairs, what is always going to be a 0 is the y. Y is 0, right? You don't go up or down. Y is 0. So we have an x-intercept at -3, 0, at 1, 0, and at 4, 0. Y equals 0. F of x equals 0. You could also do this, a little sorry, that's not, this kind of bracket is what I'm trying to make there. I didn't make it so nice. -3, 1, 4. Or you could do x equals -3, 1, 4. All of those are acceptable. All of those are ways you could see it written. Okay, x-intercepts. How about y-intercept? There's only one on this graph. -3, yeah. So when we talk about y-intercepts, the x is 0. Guys, this notation, whatever number is in this spot right here is your x, okay? So when I say f of 0, that means x is 0. If you see it on the other side of the equal sign, that's saying y is 0, okay? So get used to that. So we can write this as 0, what is that, -3? -3. Or you could write it the other ways, okay? 0, -3. Oh, sorry. Now, that was looking at a graph. That's the easiest way to find intercepts. How do we do it algebraically? So, algebraically, and we're only going to find the x-intercepts here. She should have written that, not the y-intercept. Okay? So let's find the x-intercepts when we have a function written algebraically, like this, like looks like an equation. Here's what we do. We're saying we want to know the x-intercept, so that means y is the 0. Remember, f of x is just another way of saying y. We're just being fancy. And here's the thing. If you solve this equation, what did she want us to do? Solve this? If you solve this, your solutions are your x-intercepts. They're where the graph hits the x-axis. How do we solve this? I'll give you a hint. Factoring. You tell me what method we do with factoring with this guy. Grouping. Right. So when you have 4 terms, we do parentheses around the front 2, parentheses around the back 2. And we factor out the GCF. Don't forget, anytime the first term in your parentheses is negative, the GCF is going to be negative. We can factor a 4 out there. And if we did it right, every time we do this method, you guys, your parentheses should always be the same. So if they're not, that means you made a mistake over here or over here, one of those places. How do we write our answer? Well, so look, notice I always start, for some reason, doesn't matter. I always start with my twins. Who cares? Remy? Yeah. Remy started with her GCFs. Cool. Fine. Doesn't matter. Pick up parentheses to go in. It doesn't matter. And the other one is your identical twins. Yes, Zachary, you do. A lot of people, and I don't think we've seen one of these in our math relationship together so far, where you can keep going. Zach saw it. Difference of 2 squares. Remember this? Sometimes we just had that problem. There was a problem similar to that on the quiz, where you have 2 parentheses, 2 different signs. Remember, do the square root of the first term, square root of the last term. And then I'm just going to bring the x minus 3 down. Now guys, we're at a level of math that you don't have to show every step. When it comes time for tests, quizzes, things like that, or even homework checks, if I show the work, you should show the work, okay? But on a problem like this, what we're doing, and so this step is optional. I'm going to write some work here that I don't ever need to see, okay? I'm just going to do it this one time because I lost somebody last period when I didn't show it. I'm going to set each of these parentheses equal to 0, but you can do it in your head and solve it in your head. So I'm doing x plus 2 equals 0, x minus 2 equals 0, x minus 3 equals 0. I'm solving all of these little factors that are set equal to 0, and then subtract 2, and so on. I don't need to see any of that work. You could have gone from red to this answer in your head, no problem. But those are my x-intercepts. If I graphed this, that is where the graph would hit the x-axis. It's called the solutions, the zeros, the x-intercepts. Later on, we'll call them roots, okay? But like I said before, factoring is going to pop up all the time. It's not just, oh, we had that factoring quiz, now we're moving on. We are moving on, but we're moving on and we're taking factoring with us. Aren't you excited? All right, we're going to skip these word problems. We skip a lot. There's lots and lots of material. I very, very, very carefully choose what I'm going to teach, what I'm going to cover in the homework. Take a look at this. Like, this is a big, long page. We're not doing all of these. I just said we're going to find the x-intercepts. Yeah. We haven't learned how to do that yet. I mean, it's not. No. Okay. So, take a look at this funky graph. They're putting an f of x and a g of x on there. Okay? Just to make it easier for us to be able to talk about them as I teach this, I'm going to just highlight them in 2 different colors. I can say pink or yellow. It just helps kind of see some of the picture. Totally optional. Do not feel like you have to do that. Make one correction here and extend the graph. The yellow graph needs to keep going. And just know it crosses the x-axis at 15. So just put a 15 there. It was left off. But there's still an arrow on the end. It's just I have a messy arrow. So it just keeps going, hits the x-axis at 15. Okay, let's start with domain. The domain for each of them. Domain is your x values, right? Domain is what x values make up these graphs. Well, for both of them, since they have arrows on both ends, what we know is that they keep going left and right forever. Both of them do. So we can just say from negative infinity to infinity for both of them. And we'll delve more into domain and range in other lessons. Okay, right here, understanding the language of math, especially this class, is what does this mean? It says, what are the values of x such that f of x equals 0 and g of x equals 0? What's another letter for f of x? Yeah. So what we're saying here, this is fancy talk for what are my x-intercepts. Where y is 0. What is x when y is 0? This is x-intercepts. Why don't they just ask for the x-intercepts? I don't know. That's how they wrote it. Okay? So look at the f graph. My yellow graph hits the x-axis here, here, and that's why we had to extend it. There was another one over here. Name them however you want. Just to make a point, I'm going to put that 0 in there. Where is y 0? Y is 0 at -4. Y is 0 at 2. Y is 0 at 15. But remember, I showed you a couple different ways you could have written that. The solution set, whatever. Same thing for g of x. Where is g of x 0? Yes. So where's the y 0 on the g of x graph? We also have 3 of them, right? So on g of x, we're at, I think it's a -2, isn't it? The pink graph. G of x. Right here. You see? We are. Yeah. Okay. Understand, that's not hard. Like, none of you think it's hard to finding an intercept. Understanding the question. That's what we're getting used to. Okay? The language. That means x-intercepts. Okay? How about this one? What are the values of x where f of x equals g of x. Anybody have an idea of what they're talking about there? Not the y-intercepts. Where they cross, where they intersect. The graphs are equal here. The graphs are equal here. The graphs are equal here. It's asking for what are the x where that happens. It didn't ask for the ordered pairs. What x's do the y's equal each other, okay? So that's where they cross. So I'm just maybe going to write it like this. X equals, it happens at -3, it happens at 3, it happens at 9. At those three places, the y values are all the same. Here. Two more. Where is f of x greater than g of x? That simply means above it. That's why the colors are helpful. Where is yellow above pink? Above it. Okay? That would be here. Then it dips below it. Then yellow is above pink over here. And then it's below forever. So we need to name this interval and this interval, where yellow is above, yellow is above pink. So remember, interval, x's. So only think about left and right. This one, where is this going? To negative infinity. I think you guys are getting it, yay. Where does it stop being over it? -3, yeah, right there. So yellow's above pink, then it goes below, we're below, until we get here at 3, and we're above the pink, until we get to 9. So you can see how many different kinds of questions you could be asked about these two ridiculous graphs. One more, and that's F. Now, even though F is the last piece of the notes, I will upload all of the answers. If you wanted to practice and see how you're doing with this and do more, I'll put the key up with all of these, like I said, just if you wanted to check your answers and practice some more, okay? But I'm just going to do F. So these are the ones I'm doing with you. I will fill in these and upload it just in case you want to practice, okay? Now, where is g of x greater than 0? That's above the x-axis. That means up of the x-axis. So where is my pink graph above the x-axis? So think of it as this is like your water level, right? The pink line is below the water, all here. Here, we get above 0. So that's, zoom out. So we're above 0 from here all the way to 5. Then we dip below. And then we come above water again at 7. And then we go to the right forever. We know that that arrow is not going to suddenly come back down. Okay? So I'm not going to go through all of these. I think that's enough practice. But like I said, I'll put the key up, right? And now you can practice on your own with the homework, okay? And then I'll come around and help you guys with anything you're having trouble with. And I encourage you guys to work together as well, okay? I want you to work together. So at the top, so find your 1.1 practice set 2. My notes match your notes, okay? So you have this page somewhere in there. Guys, include the A3. Always write. What I write, you write. You might be thinking, oh, wow, that was so nice of her. 21 to 25? Take a look at 25. I did not accept, so like I said, I could assign all of them, right? We just did a problem like this at the beginning of the notes. I didn't assign it because I don't think it's necessary when I gave you this one to do. If you want to do it, I will upload the key, okay? But just know I'm not assigning 16 through 20. This is just extra practice. The key will be on Canvas. You only have to do 21 through 25. So if I check the homework, that's all I'm checking, okay? So 21 through 25, you will see brackets where I said it doesn't matter, and I left them in there because it doesn't matter. I don't want you guys to get thrown off because you see a multiple choice test or something where they use brackets where I use parentheses, because it doesn't matter, okay? Cross Cross these two out. We haven't done maximum and minimum. I don't know why she included them here. Get rid of that. 21. Cross out E, whatever those are. And just like in our notes, this graph needs to be extended to 13. 13, 0. This is 13. 13, 13, 13. Okay? So you have the rest of the period to work together, ask me for help. I will upload all of this to Canvas.
So we'll try to do something more.
Just like in Algebra 2, right? Evan, I didn't assign every problem. I would tell you what problems to do. Thank you for waiting. Shoot. Let me show you guys. Listen, I have every class someone has asked me about Canvas, so just give me 20 seconds. In your Canvas, when you go to modules, if you need to see something we did in class, you go to resources. At the top of the pink sheets, there's the notes I already gave you a copy of, and then you can see by date what we did. Like Monday's assignment is here, notes, key, and then a video. We went to the Media Center yesterday. Next period, I'll upload these notes, key, put a video up. But what I want you guys to notice, and every year, I feel like I must not go over this well because I always have, like by the end of the year, I still have kids that didn't know what was in here. So if you go to Monday's A2, it's all here. Like they don't scroll. The notes that we did, so these are the notes we did on Monday, blah, 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 blah. And then keep going, and you'll get to the homework, okay? And there's the key to the homework. It's always on Canvas for you, okay? So you can check your answers, see the work. I put everything on Canvas, okay? Just want to make sure you guys know. Wait, I have this backwards, sorry. 24 is multiple choice, just so you know. Where do we start? So decreasing. Then we start increasing. I think it is. Now, I think it's on that dot right there.
That's negative.
Yeah.
But
Yeah.
then where, I did the, oh. I was looking at where Oh, yeah.
So usually it starts here at 2, right? And where does it stop increasing? Remember, it's I know, we have to get really used to reading the x-axis. That's the hardest part.
It's when y is negative 3. What are the x's? The values x are and this thing is different than the other. That's why it's confusing.
No, I looked at that. Oh my God.
This negative 3? Yeah, it's by x. It's saying that when this is at the y-axis and negative 3 right here, should I read the first one? Negative 4 over 2? Yeah, where's the 4 over 2? This part, see how it's slightly past the line? Oh, is it? Yeah, I didn't notice that quite. How's it go? Because that's the number six. It could also be like 5-4. It's just slightly over 1. 1.3. As long as it's less than 1.5. Halfway.
John? Guys, you have less than a minute if you want to pack up. I know, it's so much fun. The time just goes by so fast. You just wish you could stay here all day, but thanks for being wonderful. So true. Bye, thanks, you too. You too, thank you. Thank you, you too. Is it just water? Okay. I won't have to hurt you. You can fill up in the water cup there. Oh, yeah. Hi, sweetie, you too. Get your phone. You're welcome.